Hello students, very good morning. Today we will discuss about area moment of inertia of some regular areas. So I will discuss about rectangle, triangle, circle, semicircle and quarter circle. So let us start with the first regular area, that is rectangular area. So over here one rectangular area is shown, and along its base one axis is taken, that is named as x axis. Along its left side one vertical axis is taken, that is labeled as y axis. Then its centroid is also shown, and from that centroid two centroidal axes are drawn, one along x direction labeled as x dash, another centroidal axis is drawn along y direction labeled as y dash. So the length of the rectangle is given to us as b units, and its height is given to us as h units. So let us see the moment of inertia first of all along these two centroidal axes. So in case of a rectangular area, moment of inertia along centroidal axis in x direction, that is I x dash, is given by b h cube by 12. Now one thing to observe over here, b is that side which is parallel to this particular axis about which you want to find the area moment of inertia. Fine, so you have to keep that side, you have to take that side as b, and other side which is perpendicular to the axis about which we want to find the moment of inertia, that side will be for that side we have to take the cube, so it will become b cube by 12. Now moment of inertia of this rectangular area about second centroidal axis, that is along y direction and passing through its centroid and labeled as y dash. So it will be equal to I y dash equal to h b cube by 12, means h will be that side of the rectangle which is parallel to that particular axis about which we want to find the moment of inertia. So we want to find the moment of inertia about this particular axis, so this side will be taken as h, and we have to take the cube of other side which is perpendicular to the axis about which we want to find the moment of inertia. So that side is b, so we have taken cube of that side, so remember it as hb cube by 12. So next is moment of inertia of rectangular area about its base along x direction is given as bh cube by 12. Again same fundamental we have to follow here, that b is that side of the rectangular area which is parallel to the axis along which we have to find the moment of inertia, and we have to take the cube of other side of the rectangular area, but over here in the denominator we have to use 3, so it is b cube by bh cube by 3. Now then moment of inertia of this rectangular area along y axis is given by hb cube by 3. So same fundamental, that is parallel to this axis we have this side, so we will use that side of rectangle as h, other side will become b, so we will take the cube of that side, so it is hb cube by 3. Now next is we have a triangular area, so one triangle is shown, and we will learn moment of inertia about its base and about the centroidal axis parallel to its base. So let us first see the dimensions given over here. Dimension of the triangle is given as base is given as b units, and height is given as h units, and its centroid is labeled at h by 3 distance from its base. So centroid is marked as g. So let us first find see what is the moment of inertia of this triangular area about the centroidal axis, uh, passing through its centroid of course, and parallel to its base which is marked as x dash. So it is equal to I x dash equal to bh cube by 36, where b is that side of the of the triangle which is parallel to the centroidal axis. So this is the centroidal axis about which we want to find the moment of inertia, so parallel to that we have a side b, so we have to consider that side as b, and we have to take the cube of the height of the triangle, h cube by 36. Next the area moment of inertia of this triangular area about its base which is marked as x is given by bh cube by 12. So in the denominator we have to use 12. Along its base it is 12, along its centroidal axis parallel to base it is 36 in the denominator. Now next we will talk about circular area. So over here one circle is shown, two axes are shown, and both are passing through the centroid of the circle. So center of a circle is its centroid. So we'll call these two axes as centroidal axis. One is along x direction, so we have labeled it as x dash. Another is along y direction, we have labeled it as y dash, and radius of the circle is given as r units. So moment of inertia along these two centroidal axes for circle is always equal to pi r power 4 by 4, where r is the radius of the circle. Next is semicircle. Now over here we are given one semicircle and its radius is again r units. Its centroid is shown, and we know that this centroid is at a distance of 4r by 3 pi from its base. Now three axes are shown. First axis is passing through the base of the semicircle along x direction, labeled as x. Second axis is the axis of symmetry, labeled as y. And third axis is passing through the centroid of this particular semicircle, and it is parallel to its base, labeled as x dash. So moment of inertia of this semicircular area about its base and along axis of symmetry is equal to pi r 4 by 8. So it is ix equal to iy equal to pi r 4 by 8. So it is half of the moment of inertia of the circle about its centroidal axis. So over here it is 4, over here it is 8. Now next thing to remember about semicircle is that the moment of inertia of this semicircular area about centroidal axis parallel to its base, that is x dash, is given by ix dash is equal to 0.11 r4. This is a very important part to understand. You should keep this in your mind, that moment of inertia for semicircular area about its centroidal axis, which is parallel to its base, is given by 0.11 r4. Then in the end we will discuss about quarter circle. So quarter circle is shown here. Let us say the radius of quarter circle is again r units, and the two axes are labeled. One is both are along the two sides of the quarter circle. One is along x direction, labeled as x. Another is along y direction, labeled as y. So moment of inertia, area moment of inertia of this quarter circle about these two axes is given by pi r 4 by 16. It is again half of this particular value, that is for semicircle. So I hope the area moment of inertia of these regular areas are clear to you. So you should keep these formulas in your mind whenever you have to solve any numerical related to moment of inertia. So you will make use of these formulas.